Okay, so for those of you who don't know me at this point, which I'm sure there are a fair amount that haven't, since I'm not one of the subsystem leads, so I may not have been engaged with all of you. My name is Christian Zoni. Everyone just calls me, or my name's Christian. Everybody calls me Zoni because that's my last name. Because there are 3 Chris's of the team, right? Yes, 3. So this little lesson, although different from the most of the other lessons, is going to be a lesson on CAD, which I usually tend to call the engineer's canvas. I usually say that because, generally speaking, like in the same vein as an artist with a canvas, an engineer is only as effective with CAD, or an engineer is only as effective. Wow, I cannot speak today. This is quite the way to start a lesson. A CAD software is only good as the engineer who can use it, in the same way that a canvas and a paintbrush is only as good as the artist who can use it, is what I was trying to say the whole time. So, going with that in mind, so I guess brief question to everyone in chat. So who here has used CAD software before in some fashion? That's a no.
Me, I've used it. I'm using it right now in a class.
Awesome. So some of you have, some of you haven't. So we'll just, for those who have not, we'll take it from scratch because it's nice to be comprehensive. So what is CAD in the first place? Well, to first start off, CAD is an acronym for computer-aided design, being that CAD is basically your design and analysis tool, amongst other things, that will help you develop whatever it is you would want to develop. In terms of design, CAD is generally is capable of doing individual parts, major assemblies, and often when you get to a larger scale, which I will show you later on, full-size vehicles. You can go from modeling the smallest of the tiniest components to even the smallest of bolts, to putting that all together into a much larger assembly, and you can put that assembly into a much larger, I suppose, full assembly. But to go with your design capabilities, you also need to be able to do analysis, because if we were just doing the design and no analysis, we wouldn't be engineers, we'd be architects. So with that, we'd be doing with a lot of analysis, or with the analysis of CAD that allows you to conduct simulations on your parts, your assemblies, as well as do all sorts of semi-complex interactions with either external loads or part-to-part interaction for fitments, and a lot of other stuff that allows you to have your components and assemblies designed before they even hit the machine shop. That is the term I was looking for. So for those of you who aren't really experienced at all, you're probably wondering why you need to know this. So to put it shortly, CAD is your greatest tool as an engineer. That is what will actually, that is where if it doesn't start on a napkin or a piece of scratch paper, most of your designs will start here. It allows you to do preliminary design at a very rapid rate, because you're able to you can often create and refine basic ideas into semi-fleshed out concepts and designs. And then if it's not good, because of the way CAD is designed in its nature, you can just start over and do it again very quick, and often just as quickly. Most, if not all, designs we ever work on are based in CAD. The only time they're ever not in CAD is when they're on the most bare minimum of concepts, that being, as I mentioned, a drawing on a napkin or a piece of paper, and with very, very crude representation of what it should be. The other important thing about CAD, past everything else, is that you're able to see how your part interacts and fits with other parts before you even begin to fabricate it, which, when you get onto the order of much larger assemblies, is an absolute must, because more often than not, you may accidentally misremember a number or put in the wrong parameter. And then if you didn't have a CAD of that and you produced your part, I'm sure if anyone ever has dealt with woodworking, you might know this pain of accidentally misplacing 2 numbers, and the next thing you know, your part doesn't fit. With CAD, you can actually put the 2 parts together, and then you can see that it fits even before it's remotely even fabricated. As I mentioned before, simulation and analysis is a huge thing for CAD, such that you're able to know if a lot of these things that you're even designing will work before that, even prior to the fabrication phase. So that way, we have, even if there is such a scenario such as now, where we can't actually do much of physical testing because we don't have access to the shop, we can do, at least on a baseline level, idealistic validation of our parts utilizing the loads we know we're going to apply to it, as well as the places we know is going to be constrained. And lastly, as this is more of a fine touch, is that most models that are made in CAD software can be directly either exported from the software itself or to an external software, depending on which software suite you're using, to render it and make it very nice for presentations, which is, at least on the more professional level, CAD renders are a huge thing, especially when you're trying to market off a product. You want to have some really pretty renders, otherwise a crude screenshot may not give the best impression to an investor. So what does this all amount to? As I said before, and in the first slide, this amounts to a large-scale complete product, as seen here. So on the left, that is a pretty little render of last year's competition car, or what would have been last year's competition car, car 20. It had not been fully manufactured on account of the pandemic, so we had been, the shop had to have been closed down in mid-March, so we weren't able to fully complete the car, but it's still there for that matter. But this is, in the place of that, I decided to make several renders of it to make it look, nice and pretty, since this is the car that never was. And to put it in perspective, this single full assembly contains over 1,000 components, most of them being, well, not all of them being unique, but a fair amount of them, if not most of them, are unique in some fashion. Almost every single part on this car has undergone some form of analysis, save for the ones that are non-structural and generally didn't need it. For example, the body panels don't necessarily require analysis because they aren't load bearing. They're mostly there for regulations and for aesthetics. And all the textures here are nice and polished and are ready for a render, which is how I made this really nice looking image. If we were to compare that to what the CAD actually looks like in a screenshot, because actually I have SolidWorks open for this, since I showed that off. There we go with that, and we'll try the thing with OBS now. So if we shrink this down, this is the 2021 car, our first all-wheel drive prototype. We just call it Rev A. As you can see, it tends to not look nearly as well when compared to the render, simply because it's CAD render, or CAD's render, when it actually shows you the geometry is much more crude, because what it wants to do is show you the model, not make the model look pretty. Oh, I didn't even see the chat. What was the question there? Like when you present the car blueprints to companies. Yes, exactly that. In regards to presenting many car blueprints to companies, they're generally not like these types of renders in the in the corner. They're more those are more a 3-view drawing type of thing that you generally would show if you're doing a basic technical concept. This is more so on the presentation side, such that, like, for example, on many of our promotional materials that we have of the car itself, usually on some of these slides have them. I'm pretty sure actually it is Nick's profile picture for that matter as well. If you direct your attention over there, I don't know if anyone who would be watching this recording in the future would be able to see that, but that is also one of the renders I had made for the car. No, it actually is this very render. But it's generally just good for a presentation, as well as say we want to design the car's livery, for example, because this is just our general color scheme: red body panels, white decals, and a black frame with red accents elsewhere. Obviously, different materials, different surfaces, all interact under different light, all behave differently under varied lighting conditions. So if we wanted to see how this car would look outside compared to in a shop, you can do that, because you can change the lighting conditions of your render and make that all nice and pretty. But I think I'm getting. So with that in mind, for those of you who have never used any CAD software before, most of you are probably wondering, where does one start? So to start off with most CAD, we can go through the 3 basic subsets of CAD in general, that being parts or components, depending on which software you're using, assemblies, and drawings. For the bulk of this lesson, we'll be covering more so parts and assemblies. Drawings are something that has a bit more nuance and complexity to it, that I think would be, frankly, a bit more suited to its own lesson. So on the more basic level, we're going to cover just parts and assemblies for now. So let me actually full screen this again, because I forgot that was there. So to start off, we would start with parts, which are obviously the framework of any project that you would ever work on, because they quite literally are constructed into the assembly you want to create. So when it comes to any part, literally any part of any really thing you would design, there are three major aspects to it: sketches, features, and reference geometry. The third one isn't as relevant yet, but that will come into play a little bit later when we get into assemblies. But the first two are the important parts. So to start off with sketches, those are the very first things you do when you make any part in any model. That sets the foundation for your features and defines the important geometry and sets its parts dimensions. So to demonstrate and show you guys what I mean, because I'm sure words on a screen are not nearly as descriptive as a visual example, we'll use Fusion for this because that's what we'll be working for the duration of this lesson. Although, brief disclaimer, obviously SolidWorks is if it wasn't obvious, SolidWorks is the software that we conventionally use. However, simply because it would be more accessible for everybody else, we opted for Fusion for this lesson. And also it's easier. Fusion is easier to learn on for most people than SolidWorks because of it's a lot less feature heavy. So it's easier to work with. So we got a basic little part here. So for a sketch, that would not be this, but rather what the sketch is, hold on a second here. This little guy right down here. This little guy, which has a lot of different things on it, a lot of different numbers in different places with different little symbols here, which looks a little bit messy, is a sketch. This is literally the in context of a part like this is the first thing you would make before you do literally anything else to your part, because this acts as your groundwork. So moving on to the next slide, that should be, yep, that shows the basic interface. So we'll actually make this a little bit bigger to show that off, because I'm sure you guys can't read that. So when you're working on any, actually, is that quick question to the, because of the stream quality, is this readable? Because the text is a little small. And it's a little blurry. Up the dimensions. Are the actual words readable? So now I'll just read it off myself. So basically, when you have your interface in Fusion, there are a number of things that go into this large little sketch. So first off, when you make a sketch, you need to, and actually I forgot to implement this into the slide. So let's say we want to make a new sketch. So obviously we have to make a new design, all that jazz, and now you have yourself a little blank canvas. So first thing you obviously want to do is create the sketch and define what plane you want to use it on, because obviously CAD is a 3D thing, but sketches are defined in 2D planes. So once you select that, now you have this little canvas, which is akin to what we have in our little example thing, our example interface here. So in the top left corner, you have this little bar that says create under it. And that is basically your geometry, your shapes and lines. That is on the most basic level, what you start off to make the sketch itself. So let's trying to think if I should explain this more, if I should just do a demonstration. In fact, all right, I forgot for the practice section here, where I was actually going to demonstrate this to you guys and then have you guys create the one on the right. Or if you guys are experienced enough already, I would say just go ahead and do both. It's mostly up to you. I was trying to keep this a bit more on the open-ended side, so that way people could do what they were most comfortable with. So we'll start off with a little demonstration to make this part on the right or on the left here, this little bracket, which you guys saw earlier. So to start, we're not going to make it into 3D yet. So we're only going to make this as a sketch. So to start off, you want to create some kind of shape. That being, in this case, you'd want to start, well, first you want to actually define what portion of the geometry you want to be your origin. That is entirely preferential. Some people like to have their origin defined at the corner between two lines. Some people like to have their origin defined at the center of the circle. Personally, I go for the latter, and that's because it's easier to set because a lot of the dimensions on this drawing are relative to the center of the circle, as seen as this 70 millimeters here, for example, is taken relative to the center line of this, though it's not marked. That's a facet of that's something you're going to learn in Mech 203 when they go over general dimensions and tolerancing, or GD&T, which is absolutely crucial to understanding a lot of the intricacies of CAD drawings and why they can seem a little strange when you look at them at times, because there's a lot of stuff that's often implied but not actually directly stated, such as the implication of a center line here, which implies that the entirety of this part is symmetric about its center line. it's not explicitly stated, but it's implicitly shown via the way the dimensions are set. So back to the little demonstration. So first thing we want to do, obviously, is to make a little circle. Also, quick thing to note, I should have mentioned this, is that for the sake of ease for this tutorial, most of the dimension set will be in millimeters. However, our working unit is generally in inches because that's something that we are all used to, and it's much easier for us to go by with that. However, generally speaking, when you're an engineer, you're taught to use both. So you personally can use whatever you want, but for the sake of the team, we tend to use inches. Though there are some things that have to be set into millimeters, for example, like bearings or what's another thing besides bearings? Actually, no, I think the bearings would be the biggest ones because a lot of the Timken bearings we get are in millimeters. So back to this. So as you can see, the first thing we have is a circle in the center of our part. It has and you can see the dimensions associated with it. So it has a radius of 20 millimeters and an external arc that has a radius of 35. So the first thing we can do in conjunction with all this is with our little create tab, we already created the first set of geometry, which is a circle. So something to note already is that the circle is blue. That is not something you ever want to have upon the completion of a sketch. You never want to have that because that blue means it's undefined. So in doing so, you want to click this little guy up here in the corner that's a sketch dimension and actually define its value, which is why I had mentioned about the visible text, because this is kind of important. Your dimensions are actually your dimensions are what actually constrain your shape to adhere to a specific size or shape. Well, obviously with a circle, it's only a circle, but when you get to things more complex, such as combined arcs with lines and such, they tend to be more on the open-ended side that they need more constraint to go with. So if we set this guy to, as seen in our little drawing up here, which, can I zoom in on this? I can zoom in on this. How about that? It has a radius of 20 millimeters. So obviously something to note here as well is that the leader on this dimension only goes from the center out. That means that this is a radius one, not a diameter one, whereas the leader on this dimension in Fusion goes from end to end, which implies it's a diameter lead. So often if you don't see a diameter symbol, which you would see on, can I move this? Yeah, there you go. As seen here, this little guy is a diameter symbol for those who have not seen it. That is what differentiates the two, because often you'll have times where you may not notice or you may overlook it, and then you'll wonder why your circles are half as big or twice as big, depending on which way you're going. So set a dimension, now that's at 40 millimeters. And now if you notice, this shape is now black and I cannot move it at all because it's defined, because the center of it defines the origin, and the shape, or the point at the origin is what defines the center, such that the circle cannot move, and the dimension defines its size so it cannot expand or contract, which I also should have asked before I started this, but does anyone have any questions before I get into any more nitty gritty here? Lord, I cannot speak today. The resounding silence tells me a no. So I would hope that everyone's on the same page here. So that, we'll move on. So onto the next portion, we'd obviously want to create this little arc that's, yep, there we go, there's the cursor. So with this little arc that sits above this main circle that in this case is actually a hole that passes through the part. So I know there's a way to do it in Fusion, though I am not, oh wait, no, it's right here actually. It's a facet of the feature options, unless I'm missing something, because there's an arc there on the line. Personally, I'm not as fluent in Fusion as I am with SolidWorks, so there may be a couple of times where I may have a bit of a moment. That's just, I don't use Fusion enough, though it's a lot more easy to learn. It's one software doesn't directly translate to another. However, the principles that sit here directly translate to SolidWorks, which is why this can be used so well. So we have our second circle, and we know that that has a radius of 35 millimeters. So when we set our dimension to that, we set that to be 70. And now we have our second circle. So now moving on to the lower features down here, or lower dimensions down here, we have this little boxy region that sits under here that now needs to be defined. So we can take a line, move that down, and although it's currently going to likely just be arbitrarily defined because often dimensions are set later. I'm setting them as close as I can to their actual dimensions, so that way when I set the constrained dimension, it's a lot easier for the model to resolve itself. Because sometimes if you set dimensions way off course, the model tends to have some strange adverse effects. So now we have these guys defined, and we have these little symbols here that are defining different things of the shape. Now, some of you who may not know may wonder what these little symbols are. And these at the top here are constraints. When you're not setting numerical definition to some of these parts, you could set geometric constraints instead, which can often take the place of what would otherwise be several numerical constraints that could cause a lot of complexity on your end, because now you have 50,000 dimensions as opposed to having 2 dimensions and a tangency mate. So, or a tangency constraint. So as the name implies, or as many of these with their names imply, they're all rather self-explanatory. You have horizontal, vertical, which as seen here with this one, just orients the line vertically or orients it horizontally. You have tangent, which just makes things tangent to a circle. You have equal, which sets certain sketch segments equal to each other. You have parallel, which makes them parallel. Perpendicular, which makes 2 sketch segments like this one and this one perpendicular, as you can see down here. You have fix/unfix, which is one that you tend to not want to use because utilizing fix and unfix has a tendency to over-constrain and break sketches, because ideally they should all be constrained relative to a single reference. If you're locking one in space, then that tends to put 2 different fixture points that could otherwise break a sketch. So ideally, you don't always want to use that. There's midpoint, which sets something relative to or if you say place down I guess you can't put points in this, which is something you could do in SolidWorks. That basically defines if you have a sketch endpoint, for example, or better yet, I can actually show this with a construction line. This represents that this sketch endpoint is now constrained to the midpoint of this singular line. Instead, we want to define the center line, since, as I mentioned, the center line here is more so implied. That is because of the fact that if we set this to construction on our sketch palette on the right, this is now a construction line, which is not actually contributing to the model's geometry, but rather acts as a reference for you to put other things on there. So we have that. We have concentric, which means that both 2 circles or arcs hold the same center. That's obviously pretty self-explanatory. Symmetry means that you can then, if you select one object on one side, one object on other, and then a symmetry line or plane, that now defines your. That now means that if you don't have a midpoint dimension, or things are unique, the lines of your 2 selected elements will be the same relative to that midpoint. And then you have curvature, which actually I don't fully know. I've never seen curvature before. Presumably that would generate curvature on a static sketch or something else. So now that we have all that out of the way, does anyone have any questions about the probable, I wouldn't say wall of text because this isn't a wall, or it's not text, it's me speaking, but the mouthful, that's the word I'm looking for, the mouthful of constraints I just dropped on everyone? Or is it kind of sinking in pretty well? Okay, so I'm going to assume that you guys probably have that all down, since otherwise someone would have, oh, yeah. If anyone has any immediate questions or is immensely lost, just let me know, because I have a tendency to, I'm sure may have been obvious at this point, I have a tendency to go off on tangents, and sometimes I can get a bit over enraptured in them, and obviously if I do that and kind of get people lost, that happens. Oh, petition to use curvature. Let's give it a shot. I honestly have no idea how this one works. Constraints 2 or more objects to create a smooth, continuous curvature between them. G2 continuity. So if I select, if I selected, maybe it has to be 2 distinct lines. So we did that, then selected one, selected the other. It does not seem to want to do a thing. I don't think it likes me.
It might be for matching curves.
Oh yeah, that's what it is. Well, anywho, well, I guess in the grand scheme of things, I don't think this will matter that much because inevitably, once everything's said and done, you guys will be using SolidWorks instead of Fusion, and curvature isn't even in SolidWorks. So it's what it is. So let's get back to this little sample sketch. So as seen in the drawing on the left side, it has a overall, not an overall length, but rather a length to center of the circle of 60 millimeters. So we can set that. That is 600, not 60. That is a big old typo there. There we go. And since this part of the sketch is still here, and obviously there's a little slot here, we're going to remove that using the trim tool because I don't remember how, or I don't know how to use arcs in, yeah, that is pretty cursed, honestly. I honestly don't remember how to use arcs in Fusion because I know that's a facet of the line, but I know there's a single thing you have to do to that. I don't remember. This is also equally as straightforward. So with the trim tool, you can just pop the trim to there, and the auto trim will just select, or it will detect what line sits between two sketch points and then remove it. Filleting twice could work. However, you need to set the radius to be exact, and that would just be a bit more on the annoying side. Plus, double sketch fillet is technically not the proper way to do it because it would not create a smooth top, but rather it would create a sharp point where the two fillets would meet, which I could show in. I could just demonstrate this again in SolidWorks if anyone wants to see the actual way that it would be easier to do this. But anywho, we have that done. So now we can move on to the slot. So obviously for the slot, you'd want something rectangular. So we want to pick a rectangle from our sketch palette. And then we want to make sure we pick a center rectangle because if you do corner, then you'd have to make sure you line it up properly. So with a center rectangle, that, as the name implies, its defining point is relative to the center. So when I click this, it extrudes out, or not extrudes out, rather it expands out from the center. So now we have that, and we have our own set of defining dimensions here, such that we know the rectangle is 15 by 50 millimeters, as seen in the drawing. So we can go from that to that. That's already set to 50, so we can hit enter, move on to the 20 millimeters, and we can make that 15, because it snaps to grid, so that's why it's not like that. Oh, what in the world? Something went wrong on my screen. I think that might have been Fusion. Anywho, that's said and done. So we go from there to one second here. Just need to just got an important notification. Just need to really quickly check a thing. All right, that's good. So back to this. So now that we have our slot dimension set, we can now set it relative to the reference sides, which are these ones. So we pick this side and make sure that it is also, as seen in the drawing, 15 millimeters above, and then relative to this side should be it should be 10, which should already be set because we already defined that. And as you can see, because of the fact that all these dimensions are already preset, if you add another one, you're going to over constrain the sketch and make it a driven dimension, which basically means that the outside parameters are what define that dimension rather than this dimension or these dimensions defining other parameters, if that all makes sense. So that's a driven dimension, and now our sketch is complete. I'm sure that was a bit of a mouthful again. So anyone got any questions about the way I did this, or really did I get the point across pretty well?
Can you explain driven dimensions again?
So a driven dimension. So as I mentioned before, your sketch dimensions, besides your geometric constraints, your sketch dimensions are what actually can define the lengths of certain segments of the sketch, so the size of certain shapes and so on. However, when all these different segments are already perfectly defined, being that we have some length, a length here, and a distance from there, and we know this is centered, there is the only possible quantity that could exist from here to there is what would be the driven dimension, hence why it's called driven. Because if, let's say, I set the driven dimension, so I'll make that 10 millimeters, it's set. See, if I were to change the radius of this to say 80 millimeters, this dimension changes because it's driven, whereas all these other dimensions that are non-driven are driving. The driven dimensions tend to exist for things when you need to reference it, such as like say you need to check it on a part drawing, or someone asks for what's the value of this, but you want, or you're asked repeatedly what the value of this is. So rather than constantly going to inspect and say measuring it every single time, wait, am I doing this right? Select two vertices, and yeah, see how it shows your little dimension there. Rather than doing that every single time, you could set a driven dimension that just gives you a readout of what this dimension is without having to measure it every single time. Make sense?
Yeah.
All right, cool. Anyone else have any questions? Or are we good? Okay, so with that in mind, now that I gave the my long spiel on how to do things, because as I have learned with CAD, as it turns out, it's a lot easier to learn CAD rather than watching some idiot on a screen speak his mouth, is to have a more interactive example. So on this, if I can zoom out of this slide, if it lets me, there we go. There is this drawing on the right. So I would hope for for anyone who doesn't have Fusion installed, I'm going to also run through this myself, just in case anyone gets stuck. But I would like you guys to try this one for yourself to see, try and get the ropes for all this. And yeah, I'll zoom in on that. Or better yet, I'll actually expand the window, because I keep forgetting that this is in the corner, because on my monitor it's full size, but in OBS it's still tiny. So actually I will expand that real quick. We'll make this one there, and we'll zoom this one in. Come on. There we go. And I'll just compress this one a little bit just to make it so Fusion's still visible. How's that looking? All good? Or should I make it bigger? Because I could just full screen it, and I could just, wait for you guys to finish.
That little like upside down rhombus or trapezoid, I don't remember what the word for the shape is. Like that's open. It's open. Sorry. So like, where's the edges for that?
So, wait, what do you mean by where's the edges specifically? Because I feel like that I can't speak. Went over my head a little bit.
Like when you extrude that, what would it look like? I don't understand.
So this particular type of slot is, well, in a technical sense, this is a dovetail, which is usually used on actually on our lathe. A lot of our tool holders use dovetails, and so this, I guess, for the region of which my cursor is following, this is the actual region of the part. This is open space, if that makes any sense.
Oh, I see. I'm sorry. Okay, so that 10 millimeters at the bottom, though, it's like reaching up to it.
Yeah, no, I had the same issue. It's a little difficult to see because of the way this way Zoom likes to handle the sketch, but conventionally what you're supposed to get is a significant gap that exists between the sketch lines and the part because of misinterpretations like that. But I don't know who actually designed these drawings. I honestly yoinked these off the I just need to find some good example drawings to show, and that's kind of what I found. I blame the guy who made it, but I am actually, can you guys see the gap now? It's a little, I got to make this a lot bigger because this thing hates me. There we go. You guys see what I mean? Like right over here, or rather over here. There's that little gap, which really should be much bigger, but that's at the fault of the guy who made this. But other than that, all the dimensions are on screen, so I'd say give it a shot. And if you guys need any help, just let me know, and you could, I think everyone can share their screen on Zoom. If not, then I can enable that. And if anyone's having an issue, you guys can just share your screen, and we can go through it together. So give it about, I'll give it about 10 minutes. Or if everyone's done, you guys could all just let me know. All right, awesome, Red. So I guess if anyone needs to share the screen if they need help at some point, Ray can grant permissions such that you guys can share your screen to show whatever issues you guys may have at hand. Oh, right. Forgot about that bit. So I'm going to make an attempt to also make this a smidgen smaller, so that way, actually, this ain't. Yeah, that's not going to work. That's not going to work well at all. Let's try if I can make Fusion half the size, and then make this guy also half the size. Then drag this down here. Nope, wrong thing. Computer's not enjoying that. Can you guys still see the drawing in the corner, or is that too small? Just want to make sure it's not comically tiny. All right, awesome. So for those of you who don't have Fusion, we can give this a shot, and I can kind of take you guys along. And for those of you who may be having any issues, we can go through together. So to start off, you have to make sure the sketch palette's kind of away because that's getting annoying. And just like the last one, we're going to make the circle, or the center of the circle, the origin point, since a lot of the dimensions are taken with respect to the center of the circle. So with that in mind, we can make our first circle and go from there. And firstly, we're going to define its diameter, which is up here, 4 millimeters. So we know that's the case. So that's going to have to zoom in a lot more for that. And make the second one, which is 7 millimeters. So we can define that one. Then we're going to want to make the dovetail section below it. So we could start off by taking a line here and defining that with respect to the center line along this little guy here. So now this is here, that's there. Make that one vertical and make this one a construction line. So now it's all a little bit more clean, a little bit less numbery than it needs to be. Because for example, if you wanted to, you could say, rather than making this tangent, you could say set the distance of this guy relative to the origin to be 3.5 millimeters, but that's just putting more numbers where you don't need it. So that's why geometric constraints are often more useful, because they can negate the need for a lot of numerical dimensions, and numerical dimensions can be the things that just the slight parameters you want to change. Because for example, if I want to change the come on, let me do the thing. Let me do the thing. There we go. So say if I want to change the radius of this, or the diameter from 7 to say 9, the line goes with it because it's tangent to the circle. Whereas if we did that, and we also deleted the tangency constraint, and then set this just to be the same length and made it 3.5, and then change the value, it doesn't go with it, because now it's not geometrically constrained to the shape, but it's simply numerically constrained via distance. There's another little nice trick. So we do that, make that tangent, set that back to 7, because that's just for the sake of demonstration. And we have the second line that goes from here to there, and here to there, and that also needs to be tangent to that face, or to that circle, and same goes for that one. So that's nice and good. We got the first half of it done, and now we can move on to the dovetail itself. So for that, we want to make one line that goes down, then a second line here, a third line here, fourth line here, fifth line there, sixth line there, and a seventh line here to fully close the contour. And I'm sure this looks like complete garbage right now, but that's just because this is just a very rough representation of what we want this to look like. Is this even, oh, this one's not even vertical. Huh. So we're gonna make that one vertical as well to make sure that's nice and perpendicular to the rest of the lines here. and we want to make this one and this one equal, so that way they're the same length as specified in the drawing. I also need to make sure this is a bit more biased to the left. That way it's actually visible. Better, can I crop this? I cannot crop this. So also, it's been about 10 minutes yet. It's, oh, let me just check the, it's been a little over 5 minutes, like 5 more minutes for anyone who is still not done, unless everyone's done. So we'll just, I'll just wait till I can finish constructing this one. So 2.5 millimeters, to there. So we set that value. And now we have one of our first constraints relative to this line. We need to do 3.5, but that's already constrained by this diameter, so that doesn't need to be set. And then we need to do the dovetail. So with that, we know that we're given a length from point to point of 1.5 millimeters, so we can define that from here to there as that value. So 1.5 millimeters, there we go. We don't need to change we also need to set that this is in fact 10 millimeters because these lines here are blue because we can do this, which is what you don't want. So we'll set that to be 10 millimeters, and that would be nice and constrained. The same thing can be done on the opposite side to make sure that this is the same value, such that these lines are equal, or actually no, not even. You can make these two lines equal, and now these lines are equal by geometric relationship. Or they're not equal yet, but they're about to be equal by geometric relationship. So we set these to be equal. Now these are fully constrained. They can't move. So the last thing you need to do is finish defining the dovetail itself, which will be easily constrained by just the last dimension here, which is the 1.5 that exists, that it defines its height relative to the floor. Or not the floor, but rather this, whatever you want to call this line down here, the lowest line. We'll just go with that. So we set that to be 1.5, and there we go. Now we have our little sketch. We don't need to worry about the 45 degrees because we know mathematically that if you have two legs of a triangle that are the same length, the angle has to be 45 degrees because then it becomes a 45, 45, 90 triangle. Past that, try to think if there's anything else that is of note that I would need to mention. Obviously, I didn't need to keep the 2.5s down here because this dimension here, this 2.5 up here, as well as the 10 here, as well as these two dimensions, defined this length by simply driving it. And that is actually not the right length. So that's a problem. What is missing here? Something is missing here. What would that be? Right. For some reason, Fusion did not want to show that this point was unconstrained. So it's not actually done. Which is very strange because often sketch points should be displayed as unconstrained so that way you don't make this mistake because all the lines are black. But I guess that's a reason why we don't really use Fusion. Because you need to set this relative to the center line, but since this is symmetric about the center line, you don't need to use the symmetry mate or symmetry constraint. So we set one here, set one there. We know that that dimension is 5 millimeters, set that, and now it's done. And now if we measure it, or it's not going to give me the value. Come on, give me the value. Give me the thing. It does not want to give me that value for some reason. That's a little weird. Oh, there it is. Or rather, that's the point, more so than the line itself, which is extra weird. There you go, 2.5 millimeters, as we wanted. So in regards to the symmetry constraint, Tom, something that you'll find with SolidWorks is that it doesn't have one, but instead you can actually, for certain parts of your model, you can just make one half of it and then mirror it, which also has the same effect, which is always just a little bit more effective when you're actually when you're making more complex things. So then you don't have to do it twice. You just do it once, mirror it, done. So anyone have any trouble with this, or now that I've finished this one, or you guys think we are good to move on because it's been a little over 10 minutes. So yeah, So this is the final sketch we want. Everybody good? Going once, going twice. Anyone have any questions at all? Oh yeah, you wanted to show off your sketch. Red, could you give him screen sharing permissions, just so we can see how some of them turned out? Because obviously, my approach is not the only unique approach to this. Everyone can do different things. So one thing you're missing is that, as you can see in this part of the drawing, let me actually make it bigger. It's not one uniform one like that first bracket was. This is actually 3 separate contours. You have the contour here, and the center circle, because when you extrude this, which we'll see later, that is actually 3 separate bits. And you can see this on this is actually somewhat reflective on the version I made, how you have a line that goes through here and a complete circle, because these are actually, although not visible in 3D, these are all of a slightly different topography. The center one being slightly taller than the
I'm confused. What are you saying? That like the line, the circle for this this arc here isn't complete?
No, it's supposed to be a complete circle, because
right. I trimmed it.
No, as in if it's a complete circle, it doesn't need to be trimmed. Is what I was getting at.
I mean, I just want to make it look fancy.
No, it doesn't.
Is it
but you can make it look fancier when this is all. Once we get to the next part of this, which is extrusion.
Yeah, I can't go back. Here we go. See that? Is that better?
Yes, precisely so.
Okay, cool.
So moving on to the, so we can now move on to the next part of this wild ride of sorts, that being features. So obviously, not all CAD isn't just a bunch of 2D lines on a screen, but rather it's a conglomeration of 3D bits of geometry that are then made into a complex part. So we need to find a way to make that 2D go to 3D. That would be a feature of some kind. This in the practical sense, features are not limited to things such as just extrusions, but also say holes, slots, fillets, a lot of different things. Which as we can, what was I going to say? Yeah, features are in general a very versatile thing you can use on any CAD model, because you can use that to make your model as simple or as complex as you like. You could go from something as simple as a little 2D bracket here to something with about like 20 fillets and a countersink on every hole. You can basically do whatever you want with the features you have, but ideally you'd want to optimize them for your constraints at hand. And I think actually I could probably show you guys some stuff like that afterwards, where you'd want to constrain your models a bit, or your features a bit more, so you don't go absolutely crazy. So as I said, goes from 2D to 3D, makes your part a part rather than a sketch, and is infinitely versatile. So based on the things I just said. I like that emote in chat. That basically is what this bracket is. For those of you who haven't taken NEC 203, if I recall, this is at least a variation of the first bracket they have you make. So I just kind of eyeballed that together. So going to the next slide. I doubt you guys are going to be able to read this because of the way the first one is. But basically, once you hit complete sketch in Fusion, you're now presented with the create menu and the modify menu. Or mucus. So these are where you actually can start to make your model going from 2D to 3D. So if we close this guy up again and expand the window of Fusion, if it actually lets me, there we go. Or it will not, because SolidWorks is being more annoying today for some reason. Let's just do that and pick. Oh, that's because the Fusion one's locked. I'm a bit of an idiot. There we go. And now it's too big. So let's close it back down, back up. And yeah, perfect. So the first thing we want to try to do, and we'll actually do this with that, no, we'll try with this one. I'm sure everyone's already made this one, whereas, what's it called? as everyone already has this one. I was going to use the original one as a bit of a reference, but I'm sure that the previous slide already kind of showed off what a basic extrusion looks like, because this is simply just this one sketch contour extruded out to be a single plane, a single, like literally it looks like a toaster. It's basically a toaster. So this little guy's name is now Toaster. So that is a basic extrusion. But when you get to more complex things, such as how you have 3 individual contours in a single sketch, you tend to make things that are a little bit more convoluted, like this one. So that was that original bracket that I made before. So let me actually see, do I still have that open? I do still have that open. So for the sake of demonstration, I'll show that off real quick and we can work from there. So if we move this to be a little bit more on the isometric end, we'll make that like that, nice and pretty. When we click extrude, we have our little toolbar here, and that shows off the different parameters behind it. First thing you ever want to do when you extrude something is just like the contour, because certain things like, oh boy, is it? There we go, OBS was breaking again. Certain things that can vary from sketch to sketch is the fact that some are open and closed contours. For example, if we edited this sketch for a minute, let's hypothetically go back. Let's like say, so let's where is it? Where'd it go? Did I pull it? Oh, I pulled the dumb. I accidentally undid it. There we go. So like, let's say hypothetically we removed we made this one for construction, and we made this one for construction, such that these are no longer a part of the model's geometry, but rather, or of the sketch's geometry, but rather, quote, reference lines that you can put back into place whenever you want. So there's that, and there's that. So we finish the sketch, and we move on to extrude. Now it's a single closed contour that's just a little nub. However, most complex parts aren't this cut and dry, because they're often, you could in theory make this extrusion and then use a cut to punch the hole out, but we're cooler than that, and we don't have to. So if we undo that again and go back to the sketch, and we'll make this all uniform, or maybe make this all construction or non-construction sketch geometry again. So we get that and that, take off construction. Now it's a solid line. So we go back to that, and now we can redo the feature, and it's still like that because we haven't edited the extrude feature. So we can right click here, which down here is the timeline that actually lets you roll back things to change certain parameters. And also you right click on, or rather when you have all these little features down here, you right click on them if you want to edit them. So we go to here, and now we can select different contours, because now the contours are taken up by sketch geometry. So if we click this outer contour here, or rather, no, this needs to be the inverse of that. So we click this contour, and then we have now our direction, the distance that we want to extrude it by. There are other parameters, such as you could say, you could define it based on an object. If this was, say, a more complex sketch, you could extrude it up to an already existing surface, and it could stop there, or it could just extrude as far as you need to, which is only more applicable to cuts. You would never want to have an infinite extrusion, because then that part is, in the most literal sense, infinitely long. But infinitely long cuts are applicable, because that means it just passes through all solid geometry. So we'll set it to a distance, because that's nice and arbitrary. We have a distance that would be arbitrarily set to 35 millimeters, and you have a taper angle if you want to put a draft on it. So let's say we set this to, I don't know, 6. Now it's a little chunky at the top and a little thin at the bottom, but for the sake of ease of work, we're just going to make this 0, because normally most of the stuff we tend to make doesn't usually have the type of taper, because I don't think there's anything we have in the shop that can make that. Infinite sauce is nice. Seeing that in the chat. So now we have that. So moving on to our second part that we had here, as you can see and let me zoom in on this. This is a lot more than just a single simple little one-off extrusion. Is there any way I can make this just a little bit bigger, or does PowerPoint really hate me? I think it hates me. So actually, you know, let's just very quickly, that is an alert, my phone, let's put that away. So let's make this a little bigger, and we'll just, we'll just do this. This is actually just the dash more convenient, I think. Is this any easier to read, out of complete curiosity? Or would it have been better if I full screened it? So I can make this just a smidgen. I'll just zoom back in on it. This should be big enough. Yeah, this will do. So this one's a little bit more complicated in terms of making your extrusion correct. So since I had mentioned prior that you can actually select individual contours, you can make 3 sketch features that all do 3 different things. So we have this little part here. So for example, this part in the center. Oh wait, it's not doing the full thing. Damn it, PowerPoint! I don't like it when it does this. There we go. That's what I wanted to do. So we want to do the center portion. As we can see, there's a little 5 millimeters here. That just means we want this extruded by 5 millimeters. We can select this contour here, and then extrude that by good old 5 millimeters. And although the sketch is gone because because the software thinks that's the only time you want to use it, we can go down here into our little. Is that even visible in the window? I don't think it is. Huh. I guess Fusion isn't being happy today because normally it's visible. That's a little weird. Change that to. Let's change that to display capture, and that should actually capture the remaining bits of that. Give me a sec here. That was no better. That's because it's the wrong display. Display 3. There we go. So we have this little bar on the side here, and hold on. Now I can't see the chat because PowerPoint really hates me. Oh, the bottom left bit in that image is simply just because it did not crop correctly. That's about it. I don't know why it's doing a weird recursion there. Oh, I know the problem with that is I need to set a different display input because OBS really doesn't like me today. New source, that, there we go. And we'll just crunch that into the side here. Wait, yeah, we'll crunch that there. We'll expand this one here, and now it's cool. So, like I said before, that single piece of it that's just because it got cropped off when I made that. Though I guess the grid does line up pretty well. They were the same view, so that's kind of to be expected. But as I was saying before, you can make this sketch in the core. You can make this sketch visible again by clicking this section of the sidebar, and now it's visible again. So with that in mind, you can go to your extrusion and pick another contour, or you can pick multiple contours if you hold Shift and then click a second one and say what it specify here, 2 millimeters. So we can extrude this one by 2 millimeters. And now we have another one. And once again, we can do the same thing one more time on this third one and extrude this one by, I think I specified 3 or 4. I don't honestly remember the value. I just kind of picked them at random for the sake of demonstration. And now we have our nice little concise part. And like I said before, this was also why the dovetail was slightly different and why this line in the sketch need to be there, because this needed to be divided into 4 separate contours such that all 4 of them could be used to make different heights. So what was the question here? Which tool did you use to show the hidden sketch? It wasn't a particular tool. In the sidebar here where my cursor is, to make sure everyone can see that. I also just realized that the window for OBS is still a little bit too small. So let me just actually punch that back into the corner to show off the model. Can I zoom in on this? I cannot zoom in on this, but can I do this? Maybe. I feel like this is gonna be a bad idea, but we're gonna try this anyways. So if we really zoom in, right here, this little eyeball here is what allows you to toggle visibility for a certain part or a certain anything for that matter. You can even apply that to solid bodies. If you want to toggle visibility to this, now it's gone. Click it again, now it's back. Same thing applies to here. And this one is considered a part of body 1, which is why it disappears. Whereas this one is a separate solid body, though technically it should be merged. So actually, let me take a quick inspection of that because that doesn't seem right. Oh, that's the problem. This needs to be, you actually also want to have, I should have mentioned this as well. So let me actually zoom back out by pushing this guy back in. So this little section on your sidebar or your edit feature bar thing. I don't really have a name for that. Though I also don't know if it's visible, but this little drop-down menu here allows you to set different different conditions of which it's going to follow, of which the extrusion is going to follow. You're going to create a new solid body, which is why this was set as body 1 and body 2, which is what you don't want, because when you're to either say print this as a .stl as something you want to 3D print, or if say you'd want to, or if you want to export this to say Mastercam to CNC it, though I know Fusion has its own integrated cam software, so I know that's also a little bit redundant, but point still kind of stands. Two solid bodies are often interpreted as two separate objects entirely. So that's why you want it to be, that's why you want most parts to be a singular uniform solid body, so that way the software enjoys that a little bit more. So now this is all body 1, all joined under one sketch. And now we have our part. Red, quick question. What's the deal with time? Because I don't know if I've been going on for too long.
Currently it's almost about 6:30. It's up to you and whoever is participating how long you would want to continue.
So with that in mind, I would usually find that it kind of concluding. Actually, no, I'll do one more thing because I am. Unless, do you guys want to do assemblies? Because assemblies are a little bit more complicated. If you guys don't want to, I could always have another lesson on this another time where I can go over the intricacies of assemblies and whatnot. So that way, you guys I can show you guys how to create like full scale things. How do you combine different bodies? So, well, not quite. Assemblies are two separate components that are mated together. That's its own thing. So for example, if we were to yoink back into SolidWorks, because I still have that open, I just need to hide this because I honestly am not that well versed in Fusion in terms of assemblies. That is still something I'm kind of learning myself. If SolidWorks would actually like to show up on my monitor, please, or not. Or is it on the other screen? Where'd it go? Technical difficulties, real quick. It is not wanting to show up. Oh, wait. It's on the fourth one, isn't it? It is not. Okay, SolidWorks is officially a ghost. It is absolutely refusing to pop up onto the correct monitor. It says it's there, but it has not told me where it is. This is admittedly a little embarrassing. Because it does not want to tell me where it went. Huh. Whack. Yeah, I know you guys can see it, Nick. However, I can't see it. Like, I literally cannot see the SolidWorks window because I might have accidentally... Yeah, it says it's on... Oh, there we go. It said it wasn't on monitor 2, and it was just... There we go. So, assemblies. I can quickly go over that with SolidWorks now, while I can also... And then we can go over that a bit more in Fusion. And I would, though with assemblies, I would actually have preferred to go over it in SolidWorks because this is something you guys will likely be using far more than Fusion, because once this is all said and done, you guys will likely be using this, which to me is far more robust and a little bit more on the professional end. It's a little bit more complicated, but I can run the general gist of a basic assembly. So you can show some cooler ones, because this is the full assembly of the car. Like I said, it's about 1,000 unique, or not unique, 1,000 parts, period. I think there's about 500 to 600 unique ones on this, because every single thing is fully assembled here. Then even including the smaller things down to our gearbox, which, we'll use that for a basis of our example for an assembly. So we open up our sub-assembly here, which would be the gearbox assembly itself. If it'll open. I think it might have crashed. I think SolidWorks may have crashed. Wait, nope, we're good. Okay, so, even better. This is the exploded view. So, as I mentioned with assemblies before, rather than being combinations of solid bodies, assemblies are combinations of multiple components that are all made together to do or to be configured in a certain way. This being our gearbox that we actually have mounted, or this is being our the gearbox is supposed to be set for the 2021 car. The original one has one less shaft, so it's not much different. But the point, or rather the design, is still there, and I hope the example still holds for the most part in regards to what makes, and it tried to reassemble itself, in terms of what differentiates assemblies from just parts on their own. Anyone have any questions real quick? Because I did just kind of jump from one software to the next. So that would, I presume, to be a no. So I'm trying to think if there's anything else I'm missing besides this, because there was, I feel like there's something I might have forgotten. Oh, right. Back to Fusion real quick. There's something I did forget. If I can quickly pull that back up. One thing I did forget that I just remembered to bring up was that's display capture 1. There we go. And that can go, that's not really needed anymore, because I think that's actually, that was the last slide of the presentation. Yeah, that's done. So, because past that originally was supposed to be a bit more on the interactive side, but this will do. So they're the modify features. The most important one that would be translatable to SolidWorks would be, because you have combined and split body, which combined, since you had mentioned prior how to combine solid bodies. If, let's say, in fact, I should probably do this for the sake of example. If we edited this one such that it was although in practice this is like far more what's the word? Far more inefficient. This still works in the same way. So let's say we made this a new body, and now you have body 1 and body 3. So that's body 1, this one's body 3. If we utilize a feature such as combine, you could take this one and this one, push the button, and now it's a single body. However, now you have 4 features as opposed to 3. So ideally, that's why you want to try to also, which I should have mentioned as well, you want to try and consolidate many of your things to a single, or not to a single feature, but to as little as possible, because when you get to the more complex stuff, you will often get absolutely mobbed by just a plethora of features that you don't even remember which one is which. But when you keep them consolidated and more more compact, they're far easier to manage on the complex side. The same goes for assemblies, because if you have too many parts that are all strewn about, you don't know what goes where. As for other important features in the modify category, the other most important one, which you guys will also learn about in Mech 363, as a facet of the wow, cannot speak again. Solid mechanics is the fillet. A fillet is quite literally for those of you who don't know, a fillet is literally just a radius that goes on a corner, and that in turn is something that helps make a part just a little bit stronger. I don't think I could put this one here because of the way this tangency is set up, so we'll do it here. If it'll let me, there we go. So fillet basically rounds off a corner. You'll be seeing these a lot in a lot of other parts we make, that fillets are generally just your multi-purpose, either to make the part look nicer, or because in the context of, say, what's a better example here? I was wanting to use that corner. I can use the dovetail because that helps illustrate my point a bit more. So if you guys can see here in the dovetail, this vertex is a very, very sharp vertex, which, as you learn in Mech 363, sharp corners in general are no good, because those are stress concentrations. That's where fillets come in. If you radius the corner, if it'll let me do that, if you radius the corner, now it's a much smoother corner with a little bit more material, and it's a much smoother transition from one to the next, which is way nicer in terms of stress on the part compared to just a sharp corner, because that is more likely to break because the stress is likely to concentrate there. But that's more of a solid mechanics thing than a CAD thing. But that's still important to know, because otherwise it wouldn't really make sense to say why these exist in the first place. Anything else I may have forgotten to bring up in this? Oh yeah, reference geometry, which is something that was important to assemblies. So this little drop down here is construct. That lets you create all sorts of different things, that being the biggest ones being planes, axes, and vertices, which are all or planes, axes, and points. When you're making assemblies, which we can get into in the next lesson, so I guess I can kind of leave this off here as a bit of as a transition point. basically when you want to mate multiple parts together, you often want to use said reference geometry. For example, if you want to make two axes concentric, you either make the inside faces concentric. However, if this is to change, then that inside face is gone. The mate breaks. You can apply an axis, so an axis through a cylindrical face, and now you have this little guy, which is an absolute representation of the center of this circle. There are far more implications to it than that. For example, you can define, say if we want to make a point that is defined as the concentric to this axis, but also coincident to this face. We can do that now because we have a point between, would it be a vertex or to be a edge in a plane? Can't remember which one it was. Wasn't two edges? Wasn't that one? I could have sworn it was not three planes. Could I do edge in a plane? Did that work? I don't remember. It did work. And now we have a little reference point here. And so if you need to do a mate between two other parts at another point, you could use this reference point to now act as a geometric reference, which gets very important the more, I guess, the deeper you go down the assembly rabbit hole, for lack of a better term. So I think I've gone on for long enough, but rather I think I've covered enough material for today such that I wouldn't, tire you guys out with a Lord knows how long lecture of everything. So I think now would be a good time to stop if you guys are down with that. Mm-hmm. That is a lot of hoodies. So you might be cold. But yeah, other than that, anyone have any final questions or remarks? Anything they want to say? Anything at all? Mm-hmm. So I think with that, I would want to, I guess, call this. Oh yeah, right. There is also that. Yeah, that is a chassis thing. Yeah, there is that chassis meeting tomorrow. So that is at 11 a.m. And yeah, I'm not fully sure on what's to go on in that meeting, but if you're a chassis person, you should definitely go because it's important. So yeah, I think that is about it. So I appreciate all you guys for coming to this. I've never actually done a lesson before, so this was a bit of a new experience for me, and I hope you guys enjoyed. And I wasn't too boring with my my means of speech, but